Learners, welcome to Nios Studio. I am Dr. Joshit VP from Central University of Kerala. Today, we will discuss about the process of scientific inquiry, engaging learners in scientific processes. So again, what is scientific inquiry? Scientific inquiry is using evidence from observations and investigations to create logical explanations and answer questions. See, we will just see the difference between scientific method and scientific inquiry. See, we have two important things, scientific method and scientific inquiry, where method will be more familiar for everyone. See, scientific method seeks to answer one question, whereas scientific inquiry does not limit to one, does not answer just one. So, it goes for many questions. Again, here it is one, but here it is many, because it has got no limitations. Whatever which come across, which come in between will be answered. Now, scientific method is linear, whereas scientific inquiry is non-linear. In scientific method, communicating the results at the end of an experiment. In scientific inquiry, it is a constant communication, where communication is continuous, and constant communication is necessary throughout the entire process from start to finish, not just to tell or defend the results. Again, I told, we have already told that it is many things, many observations that we do in between. So, each and every time when you have to communicate something in between, it should be done in the case of scientific inquiry. Now, we just go for a definition of scientific inquiry, which has been given by Sandoval and Millwood in 2005. It is a process of posing questions, gathering and analyzing data, and constructing evidence-based explanation and arguments by collaboratively engaging in investigations to advance knowledge and develop higher order thinking skills. Again, we come with a question, we just gather or analyze data, and we just construct evidence-based explanation. This has been a very good definition which has given for scientific inquiry. Now, see the steps of scientific inquiry. First one, posing questions. Next, formulating a hypothesis. Third, conducting an investigation. Next, gathering and analyzing data. And the final one, it is forming conclusions based on evidence. So, see, first we pose a question, after that we just go for formulating a hypothesis. After formulating a hypothesis, with the hypothesis with us, we just conduct investigation. And after conducting investigation, all the results, data and observations will be analyzed, and it is really coming up with conclusions with the solid evidence that we have. That is what is the steps of scientific inquiry as we have discussed now. Now, we just go through the three major stages of scientific inquiry. First one, initiate and plan. Next, perform and record. Third, analyze and interpret. So, first is the process of initiation. You need to initiate, you need to plan the activities, because only initiation will lead to further. After initiation, then what you want to do? You want to just go for the real performance. perform the experiment, perform the task, perform the observation, just get the record of readings, get the thing, get what you want to record. So, each and everything as a part of your performance, as a part of your observation, as a part of your experiments, the data you get, you just record. Then we go for the recordings, we just analyze the recordings, we just analyze the observation, we just analyze the data, and finally we interpret. This is what is the 3 stages of scientific inquiry. Now, how learner is engaged in scientific inquiry? See, for the learner will be engaged with scientifically oriented questions. Learner give priority to evidence in responding to questions. Again, priority comes from learner. Again, priority comes for evidence. Now, learner formulates explanations from evidence. Next, learner connects explanations to scientific knowledge. So, they formulate explanations and after that they connect explanations to scientific knowledge. Now, learner communicates and justifies explanations. So, whatever the explanations that he has given, he will be justifying the observation and he will be communicating the essence of that. Now, learner foster deep fundamental knowledge and a strong conceptual framework. So, as part of scientific inquiry, definitely we should have a fundamental knowledge and conceptual framework. Now, learners build on and foster natural problem solving abilities. Through the series of activities and through the process of scientific inquiry, automatically we develop some skills. For problem solving, which we can call it as a natural acquisition. Now, learner work directly with students on ideas, beliefs and conceptions. So, again learner works with his ideas, it is a self idea, self belief or it is a conception. Now, learners provide effective guidance and modeling for students on queries, because as part of scientific inquiry, providing guidance and having some models is very important. Now, what does scientific inquiry leads to? Scientific inquiry leads to understanding of scientific concepts, appreciation of how we know and what we know in science, understanding of the nature of science, skills necessary to become independent inquiries about the natural world, the dispositions to use skills and abilities and even attitudes associated with science, identify questions and concepts that guide scientific investigations, design and conduct scientific investigations, use technology and mathematics to improve investigations and communications. So, all these things are developed as part of scientific inquiry. Now, learner can formulate and revise scientific explanations and models using logic and evidence. So, again this is generated because we are going to revise, we are going to reformulate, because reformulation takes place because of the new evidences that we get. So, reformulation and rearranging based on logic and evidence. Now, recognize and analyze alternative explanations and models. As part of scientific inquiry, one can recognize, one can analyze alternative explanations and models, can communicate and define scientific argument, can communicate as well as to defend a scientific argument. Now, we just see how technology promotes inquiry. Studies have demonstrated the positive impact on student learning gains on target scientific concepts as a result of the technologies implemented. See, potential setbacks of technology integration. First one, usability and functionality, time factor, accessibility to technology, mobile technologies and m-learning, social media, simulations or virtual environment, digital videos, technology enhanced curricula, etc. See, we are in a period where the conventional classrooms has got a paradigm shift, where people learn from online medium, where technology has penetrated even to the creativity of a teacher, because teacher can be more creative with the help of technology rather than keeping his ideas alone. So, this is a technology integration. Maybe someone will be seeing that creativity of the teachers are lost because of technology, but it is not the case. Creativity of the technology, creativity of the teacher has been modeled with reference to the technology mediated environment, with reference to the technology mediated learning, where teacher is more stable and teacher is more confident for his presentation or for his knowledge. Now, see, inquiry outcomes through professional development. Improvement of inquiry outcomes through professional development practices can be done through inquiry workshops, curriculum development experience, mentoring and peer collaboration. Workshops are mandatory requirements, because without having a proper workshop, you will not comprehend the technology. So, after the workshop, whatever the experiences or whatever the knowledge that you have generated should be modeled in your curriculum development process, and proper mentoring has to be done, and proper peer collaboration also should be done, because peer collaboration generates again knowledge, or peer collaboration refines the knowledge that you have already generated. Now, using scientific labs can be considered as a scientific inquiry method. Providing students with an opportunity to do labs, especially those that are hands-on. Although most inquiry labs and activities are hands-on, not all hands-on labs and activities are inquiry oriented, necessarily mean they are doing inquiry. Can all science lessons be taught through inquiry? This is a thing which teacher has to decide. As teachers, we decide which lessons are best presented through direct instruction or a teacher-led approach, and which one can be guided through inquiry. So, there is no preconceived notion that every science lesson should be given through scientific inquiry processes. Now, how do you assess inquiry-based learning? See, normal classroom assessment is not possible for inquiry learning. Now, most of the assessment has just reached to a stage, everything has become a multiple choice assessment. So, it is not suitable for inquiry based learning. So, use alternative methods of evaluation, using portfolios, writing journal entries, self-evaluations, reflections, etc., and just you have a frame logic with a framed rubrics in conjunction with objective type question. So, the knowledge will be assessed through objective type question, and your process of inquiry or how the developmental stage you are being in will be assessed through the entries or portfolios which you are assessing or evaluating through proper rubrics. Inquiry is soft science and not content related. Is that true? Definitely it is true. Everyone can have the sense of inquiry. So, inquiry has become a soft science. Soft science leads us in each and every occasion. So, inquiry has that skill. Now, we have a question, can students with learning disabilities can learn through inquiry? The answer is definitely yes, because inquiry based instruction can and should be done equitably at all levels and for all learners. Definitely, students with a learning disability can also learn through inquiry. Now, we will see the principles of scientific inquiry. Pose significant questions that can be investigated empirically. Link research to theory. Use methods that permit direct investigation of question. Provide coherent chain of rigorous reasoning. Replicate and generalize. Transparency and scholarly debate. All these things which we are just discussing on different terms. See, we have discussed this also in other areas where how these things work together. Now, these 6 terms which you can just call it as the principles of scientific inquiry. Now, as we have seen these 6 steps, like linking research to theory, how does you link? You link with evidences. Become transparency and scholarly debate means you will be transparent in your reporting, transparent in your conclusions, and you are ready to have any type of scholarly debates. Now, we just have a final wind up of our session. Inquiry based learning has long been regarded as a valuable, student centered approach in education. Inquiry based learning promote autonomous learning and create lifelong learners and results in increased motivation and ownership. Finally, the youth of today who must sort through the vast information available to them on their fingertips need these skills to determine what is relevant and what is accurate. So, today we have discussed about scientific inquiry in different way. We have just gone through the principles, we have just gone through the stages, and we have just gone through the steps of scientific inquiry on an alternate notion. And we have just seen how the process of inquiry can be developed for science students. Hope you understand this session. So, this will be another attribute to scientific inquiry or scientific method or scientific attitude when we come across such concepts of science. So, thank you. Have a nice day.